In this lesson, we are going to be looking at angles in regular polygons. These are all questions from exam papers, so you will have an experience and a feel of what the exam questions will look like when they test you on this topic. I've got 5 different questions that I'm going to go through, starting with the first one. So, what kind of knowledge do you need? Before we start, let's give you some information that you need to be wary of. The first one is you need to know what the angles, the sum of the interior angles in a polygon add up to. And we use the formula n minus 2 times by 180. So this formula right there gives you the sum of interior angles. And we can use this to find the interior angles of any polygon. The second one that you need to know is the exterior angles. The exterior angles of any polygon are equal to 360. So if you want to find out how many sides it has, you just need to do 360 divide by one of the exterior angles, and then that will tell you the number of sides it has. You could also use this 360 and manipulate it by doing 360 divided by n, and that will tell you what one of the exterior angles of the polygon. So let's dive straight into this question. We are told that A to B, B to C, and C to D are 3 sides of a regular polygon P. So we don't know how many sides the rest of this polygon has. We just know that it is a regular polygon. Now, what does the word regular mean? Regular means that all the sides and all the angles of this polygon are exactly the same. Okay, so this side here is the same length as this, same length as this, and this angle here is the same as this angle there. Okay, and we are also told that this is a 12-sided polygon. So this is a 12-sided polygon. Okay, I can't draw the rest of it. Okay, show that polygon P is a hexagon. So I have to show that this is a hexagon and therefore it has 6 sides. I can't just use this though. Okay, I can't just put 6 in here and then minus 2 times by 180. I have to show that to be the case. And I'm going to do that by using the squares. So let's start now. We know that this square here is going to have an angle of 90 degrees, and so will this one right there. Now, what if I can find this angle right there? And if I find that angle, then I can use the angles on a point, which add up to 360, to find this angle in pink, which will tell me what the interior angle of polygon P is. So let's use this information about this being a 12-sided polygon and use our formula. So we're going to have 12 minus 2. 12 is the number of sides, and we know it's got 12 sides or 12 angles, and then we're going to times that by 180. So that's going to be 10 times by 180, which is 1,800 degrees. So the sum of the interior angles, all of the angles, all 12 angles, add up to 1,800. What does one angle equal then? We just need to do 1,800 divided by 12, and we get 150 degrees. So one of these angles is 150 degrees. So that is 150 degrees. Now, we know that the angles on a point add up to 360. So if we know that one of them is 90, this one is 150. To find this, so we just need to do 90 plus 150, which equals 240, and then 360, take away 240, which gives us 120 degrees. So polygon P, its interior angle is 120 degrees. So how do we show that this is an hexagon? Well, let's use our formula. The sum. I mean, we can do this in a number of ways. Okay. Some of you may decide you want to find the exterior angle and then divide that by 360, and then that will tell you exactly what you want. Okay. In fact, let's do that. That's probably quicker than using the sum of the interior angles. So if we know that the interior angle of our polygon P is 120, and then we just extend this out, what does this angle equal? The exterior angle here. Okay, it's going to be angles on a straight line. Doesn't look very straight here. Let me draw this again. So if this is 120, and then we just extend this line out, what does the exterior angle equal? That angle here would be 180 minus 120, which is 60 degrees. So the exterior angle of polygon P is 60 degrees. So therefore, if I now just do 360 degrees divided by 60, and that gives me 6. So I know that it has 6 sides, and therefore it's a hexagon. So let's move on to the second question. The diagram shows a regular pentagon and a parallelogram. Work out the size of the angle marked X. You must show all your working. All right, so what do we have? We have a pentagon here, and we have this parallelogram. And we have to find this angle X right there. Now, with the pentagon, it's a regular pentagon, which means all these angles are going to be the same. Okay, so let's focus on this particular one. Let's find what one of these angles of the pentagon is. So we're going to use our formula, n minus 2 times by 180, and then we're going to divide that by 5 because the pentagon has 5 angles. So that's going to be 5 minus 2 times by 180 divided by 5. That will tell us what one of the angles is, and that gives us 108 degrees. So that means this, all of that, is 108 degrees. We just need to find what X is. Now, if we look at the parallelogram, what information do we know about the parallelogram? These two lines are parallel, so are these two, but we just focus on the top two for now. So we just focus on this. When we have a line that comes in like this angle here and this angle here, they form a co-interior angle, which means they both add up to 180 degrees. This is the rule that you may be familiar with. All right, these two add up to 180 degrees, and these are our two parallel sides, just like we have right there. Okay, so to find out what this angle right there, just there, is, we do 180 take away 117, and that gives us 63. So we know that this angle right there is 63. What will X be? Well, to find X, we just do 108, because remember, the entire angle is 108, take away our 63, and that leaves us with X, which is 45. So that's what X is equal to. Question number 3. R, S, and ST are two sides of a regular 12-sided polygon. So it's a 12-sided polygon. R to T is a diagonal of the polygon. Work out the size of the angle STR. So STR, this angle right there. Let's mark that in. Working that out. You must show all your working. All right, so let's use this information about being a 12-sided polygon and find out what one of the angles of the polygon is, which would be this one. This is the complete angle, obviously. All right, so that will be 12 minus 2 times by 180 and divide that by 12. That gives us 150 degrees. So we know that this angle here is 150 degrees. And what do we have? We have an isosceles triangle right there. Why is it an isosceles triangle? Because it was regular. So these sides are exactly the same. Okay, so that side and that side are exactly the same. Therefore, if it's an isosceles triangle, then these two angles will be exactly the same too. They will be equal. So I do 150, take away from 180. That gives me 30. And then I'll do 30 divided by 2, which is 15. So STR, angle STR, is equal to 15. Okay, question number 4. We have a regular octagon. Okay, we are told that ADJ is a straight line. We are told that angle BAD is equal to angle CDA. So let's see what that is. So BAD, which is this angle here, is equal to angle CDA, this angle. So these two are equal to each other. Okay, and of course, this line here is equal to this line and also to this line as well, because it's a regular octagon. So all the sides are the same, even if it doesn't look like it isn't. Okay, you can see that it doesn't look like they are the same. This line is longer, but it said it's regular, so they are the same. Show that angle CDJ is equal to 135. So show that CDJ, this angle here, is equal to 135. 5. So this is what we need to find inevitably. So where do we begin? Let's start with our octagon. Let's find one of the interior angles of our octagon. So this one and this one, any of them. Okay, let's find what those angles are. And of course, you can see that we're most likely going to concentrate on this quadrilateral here. Okay, so let's go ahead and find that. So it's an octagon, so 8 minus 2 times by 180. And then we're going to divide that by 8. And that gives us 135 degrees. So this angle right here is 135. This angle is also 135. So what about these angles right there? What are they going to be? Well, this straight line right there will have divided this up into two angles, one of this one being 90 degrees. So if I know that all of this is 135, because remember, all of these are 135, I can just do this 135 and take away the 90. Okay, so this one will be 135, take away the 90, which is 45 degrees. So this is 45, and this is also going to be the same because same principle. All of that is 135, take away the 90. Now, that just leaves me to find this, which I'm sure you've worked it out. Angles on a straight line add up to 180. So that's going to be 180, take away your 45, and that gives 135 degrees. On to the last question, number 5. We are told that ABCDE is a regular pentagon. So it's talking about that right there. We are told that BCF and EDF are straight lines. Work out the size of the angle CFD. So CFD right here. We are working out this angle here. You must show how you get your answer. Right, let's start with our pentagon right there. So it's a regular pentagon, a pentagon, 5-sided. So 5 minus 2 times by 180, that will tell us, and then if we divide by 5, that will tell us one of the interior angles. That gives us 108 degrees. So this here is 108, this is 108, so on and so forth. More importantly, this here, which we are going to concentrate on, is 108 as well. Now, let's focus on our triangle right there. If we extend this angle, so we have an angle on a straight line, this is a straight line, this angle can be found quite easily by doing 180 minus 108. So this is going to be 180 minus 108, and that gives us 72 degrees. Now, don't be forced making an assumption about this triangle being an isosceles triangle, okay? Because there's nothing in the question to say that it is, although it may look like one. Instead, you do this. The same thing applies here. This is 108, right? So this will also be the same as before. That will be worth 72. And now you've just proved that this angle here is 72, this angle here is 72, therefore making this an isosceles triangle. Okay, so you have to prove that. So now, in order to find what this angle here is, we are going to do 72 plus 72, which is 144, and then take that away from 180. So 144 take away from 180, that gives you 36. So the angle CFD is 36 degrees. Hope you enjoyed this lesson. Please go and check out the other videos on my channel on the various playlists. Don't forget to give this video a thumbs up, and please share the channel with your friends and your family. Goodbye for now, and I'll see you in the next video.